So we're going to go over the distance from a point specifically to a line. And this is 9.5 in your textbook. They've given us two formulas. When in two space, and we're given the equation of a line in Cartesian form, the distance between the point and the line is known as the magnitude of our Cartesian form when we put our point into it, divided by what usually looks like the magnitude, but the root of a squared plus b squared. Okay, and we'll get into a question dealing with this one. And then in three space from a point to a line, it's the cross product between the line and the point divided by the magnitude of the point. Okay, so let's get into an example so we can see what this looks like in the question. So we'll write our formula out just so that we remember it. Our a x naught plus b y naught plus c, all divided by the root of a squared plus b squared. Did we leave anything out there? I think that's good. And double check we leave anything out. No, that's right. Okay, so the question's asking us determine the distance between our point P to the line with the equation, and this equation is in vector form. Okay, so out of the question we can denote our x naught and y naught. We know those will be the coordinates that we'll need to plug into this part of the equation. The problem is we're in vector form, and we need to change it to our Cartesian form. We have ax plus by plus c. Okay. Does anyone remember how we change vector form to Cartesian form? The normal. How do we find the normal of this? Okay, so our direction vector, because we're in two space, if we were related to our slope y-intercept, remember y is equal to m, which is very important for this part, x plus b. Our m in this case, our y coordinate is 3, which is the rise, and the run is -4. Okay. If we need to find the normal in two space, we can find the negative reciprocal of that slope. So the negative reciprocal would make this a positive value, and would be 4/3, which means our new coordinate, or our new direction vector, would be 3, 4 in this case. So when we go to plug it in, our a value will be 3, and our b value will be 4. So we have, whoops, sorry, I was about to write 4 in. 3x plus 4y plus c, and usually equal to 0. What else do I have to do in order to solve for our c value here? Which one do I plug in? Yes, we plug in the values that are actually on our line here. So these will represent our x and our y, which will help us solve for our c value. So we have 3 multiplied by -2 plus 4 multiplied by -1 plus c is equal to 0. -6 minus 4 plus c equals 0. C is 10. So our Cartesian equation of the line is written as 3x plus 4y plus 10 is equal to 0. So there's our Cartesian form of the line, and the point was denoted at 15, -9. 15, -9. So when we go to plug this into our equation for distance, we're going to have the absolute value of 3 times 15 plus 4 times -9 plus 10 divided by the root of our a value, which is 3 squared, and b squared, which is 4. Okay. And we work from here. We'll end up with the absolute value of 45 minus 36 plus 10, all divided by, what is that? 9 and 16, so root 25. This leaves us with 19/5. Is that right? Okay. So the distance between this point and our line is 19/5. And we would just write it as 19/5 units if we're going to give it any type of measurement in this question. second part of this is we're going to look for the distance of a line. This time we're in 3 space. Okay, so we're looking for the distance from this point to our line denoted like this. Okay. Now m is going to stand for our direction vector in this equation. So our direction vector is 0, 1, 1. And we have to figure out what the coordinates of QP would be. P being our point in space and Q being a point on the line. Okay. So in order to find out the actual position vector for QP, we need to subtract our two values. So we take Q and subtract our P, which will give us 1 minus -1 for our X value. 2, subtract 1 for our Y, and -1 minus 6 for our Z. Okay. This will give us the value of vector QP. We'll have 2, 1, and -7. Okay. So this is our vector QP, and we also have our vector M. So now once we have these values, we're going to plug them directly into the formula. We'll have to use cross product, but just so we can see what everything would look like, our direction vector is 0, 1, 1, cross QP, which is 2, 1, -7, all over the magnitude of our direction vector M. Since we have to do our cross product, we're looking at A1, A2, A3, B1, B2, and B3. We'll do the cross product to start off, and then we'll plug that value in at the top. So the cross product of QP is equal to A2, B3 gives us -7, subtract B2, A3, 1 is our X value. A3, B1 is 2, subtract B3, A1 is 0. And for our Z, A1 times B3 is still 0. No, sorry, B2 is still 0. And B1, A2 is our value of 2. Okay. So -8, 2, and -2 is our cross product here. So now that we have these values on top, we're going to have to find the magnitude of this. And the magnitude of these values, if you guys remember the magnitude of something, you can find it by taking its dot product. So we'll call this new vector, I'm just going to call it for, what's a good letter? K. Okay, we'll call it vector K. In order to find our magnitude, we know that if we find the dot product of K and K, it'll actually give us the magnitude of K squared. In other words, to find the magnitude of K, we take these values and square root them after we've squared them. So -8 squared plus 2 squared plus -2 squared. I'm sure if you guys remember this process. That will give us 64 plus 4 plus 4. I feel like it was a different value at one point. Okay. Which just gives us the root of 72. Root 72. So the magnitude of our cross product is root 72. So we're looking at our distance. Our numerator is root 72. And our denominator was the magnitude of our direction vector. Okay. Our direction vector was 0, 1, 1. So same idea to find the magnitude. We're going to do the exact same process we did before. We find the root of 0 squared plus 1 squared plus 1 squared, which will give us the root of 2. So we get root 2. This can be split into root 36 and root 2 over root 2. Our two roots cancel out, and we get the value of 6. So the distance between this line is 6 units.